Pauli's exclusion principle. No two electrons in an atom can have the same set of 4 quantum numbers. So it states that no two electrons in an atom can have the same set of 4 quantum numbers. All 4 quantum numbers of 2 electrons in an atom cannot be the same. That is what is stated in Pauli's exclusion principle. In other words, it is given that only 2 electrons may exist in the same orbital, and these electrons must have opposite spin. So we know that only 2 electrons can be accommodated in an orbital. If we take the example of the first energy level, when n is equal to 1, L equals 0 and ml equals 0. So when L is equal to 0, it is the S subshell, or we can say it is the S orbital. An orbital is a place, an area where you have the maximum probability of finding electrons. So when in the S orbital or S subshell, you know that there are only 2 electrons in that particular orbital, and both those electrons can have the same N, same L and same ml values, but their spin will be different. That spin will depend on whether it is rotating, that electron is rotating around its own axis in the clockwise direction or in the anti-clockwise direction. So that spin will be plus half or minus half depending on the rotation of the electron around its own axis. Of course, the electron will be going around the nucleus, but it will also be rotating on its own axis, and upon that will depend the spin quantum number. So only 2 electrons can be there in a particular orbital, and those electrons should have opposite spins. So the spin quantum number will definitely be different. But N, L and ml values can be the same for a set of 2 electrons in a particular orbital. So only 2 electrons may exist in the same orbital, and these electrons must have opposite spin. So that is Pauli's exclusion principle.